All right, so while you're learning this, I would suggest you have available to you on your desk, printed out or available. I would have the polyatomic ion list. I would have this flow chart. So all of the nomenclature slides are to explain this flow chart. And of course, a periodic table. All right, so I'm going to go through all these and kind of go through the steps, and then hopefully it'll start clicking. You're going to have plenty of opportunity to practice nomenclature on homework 8. Homework 9 is equations, but a lot of it's in words. Also lab 8, okay, we'll have a lot of opportunity. You're going to get plenty of opportunity to practice nomenclature. So let me go ahead and go through these. And it's going to be a little bit of screen management here. So the first one is sodium oxide. All right, so sodium oxide, you say sodium oxide. So let me write this down. It's sodium oxide, and we'll just do maybe 2 at a time. Chromium 3 sulfide. So sodium oxide. Chromium, magnesium phosphate. Let's just get 2 written down at a time. Okay, so the first step in nomenclature, if you look at the flow chart, is it ionic? I know this is a little small, but you should have it too. Ionic, covalent, or an acid. It's ionic automatically if it contains a metal. So that's where your, see what I mean by jumping around? Your periodic table. Remember, everything to the left of the stair step is a metal. Sodium is over here. That means it's a metal. We'll do magnesium as well. Magnesium is over here. So if it's ionic, then what you do is you have to come up with the charges. So for ionic compounds, you get the symbols. This is for ionic. You get the charges. I'll do the first couple more slowly, and then you put together. And the goal is the charges have to cancel. All right, so for sodium oxide, the symbol for sodium is Na. The symbol for oxide is O. And so if we look at our periodic table, sodium is a representative metal. It's in group 1. So representative metals in group the charge will be the group number in the ones place. So it's a +1. Oxygen is a non-metal. Non-metals, you look at the group number, which is 16. You subtract take the number in the ones place, which is a 6, minus 8, -2. All right, so oxygen will be O2 minus. I circle my charges. That is completely unnecessary. It's just something I do. So there's a lot of ways to figure it out. But first thing, metal, non-metal. Non-metals, the group number in the ones place -8. So these will be, this is 17, -1, 16, -2, 15, -3. Then to put them together, we need to make the charges cancel. To make them cancel, we go to the least common multiple of the charges. They're 1 and a 2, so that means we need to get to a 2 and a -2 to make the charges cancel out. That means we're going to need 2 sodiums and 1 oxygen. The magic numbers you use become your subscripts. That's a U. So this will be Na2O. We don't write the 1. The 1 is understood. Okay. For magnesium phosphate, the same approach. So magnesium is a metal. It's in group 2 right here. So that means it's going to be Mg2+. Phosphate is a polyatomic ion. So, and we know that because it ends in 8. And so phosphate is PO4 3-. All right. So then we need to get to the least common multiple of the charges. We have 2 and 3, so that's going to be 6. It means we need 3 magnesiums and 2 phosphates to get to the 6. So it'll be Mg3. And then if you have a polyatomic ion and you've got more than one, you've got to put it in parentheses. See if you don't put the parentheses, see what that looks like? So the parentheses say it's 2 of that whole thing. Okay. That's the approach. Next is chromium 3 sulfide. All right, so chromium 3 sulfide, I'm going to abbreviate it. and nickel 2 nitrate. All right, so chromium is a transition metal. It's right here. That means that we can't tell the charge from where it is, but we're told what the charge is. So it's Cr, the number in Roman numerals is the charge. That's +3. Sulfur, nonmetal in group 16, so it's S with a -2. So we do that same thing that we did over here. We need 2 of these and 3 of these. You don't have to show this work on a test, by the way. So it'll be Cr2S3. Nickel 2 nitrate, same idea. Nickel is a +2. So if you see the number in Roman numerals, you automatically know. That makes it actually easier. Nitrate is a polyatomic ion. It is right here. It's NO3 with a -1 charge. So we're going to need 1 of these and 2 of these to make them cancel. Ni, NO3, 2. Once you've done a few of these, it starts going faster. Because it's like learning a language. Once you get a little bit better at the language, you get, you speak it a little bit better. All right. So next one is ammonium carbonate and then carbon disulfide. All right, ammonium carbonate, those are both polyatomic ions. So ammonium is NH4+, carbonate is CO3 2-. That's something you just got to get used to recognizing them. NH4+, CO3 with a -2. I'm not going to show all these steps now since I've done several of them. So NH4, 2, CO3. Always write the positive ion first. All right, oh, I see something in the chat. What's in the chat? All right. Okay, carbon disulfide. So now, where's my periodic table? Is here. Carbon disulfide, this is 2 nonmetals. Right? So that means we don't deal with charges. This is a covalent compound. If you look here, right, covalent binary compound, 2 elements, both of them are nonmetals. The hint is if you see prefixes like mono, di, tri, that is a hint. So carbon is C, and this is literally carbon and 2 sulfurs. So it's CS2. That's it. These are the easiest to come up with. All right, the next 2 are dinitrogen trioxide and hydroiodic acid. So dinitrogen. If I just move this over, we can just see it, right? Yeah. Okay, so dinitrogen trioxide. And hydroiodic acid. All right, so dinitrogen trioxide, again, 2 nonmetals, nitrogen and oxygen. So we just use the same idea here. This is di is 2, so it's N2O3. Again, this only applies if they're both nonmetals, but they're both nonmetals. No charges, because they both be negative, right? Doesn't make sense. Okay, now, acids are tricky. We know it's an acid because of the word acid. Acids come in 2 flavors. Again, I know this is small on the screen, but there are what are called binary acids, meaning they're hydrogen and 1 other element, or what are called oxyacids or non-binary, where there's 2 other elements. They're also called oxyacids because they typically contain oxygen as one of the elements. So binary acids always begin with the prefix hydro. So then think of an acid as a ionic compound where hydrogen is the metal. So hydrogen, if hydrogen was a metal, it's in group 1. So it'll be a +1. And then iodine, iodic, iodine. Okay, iodine is a nonmetal. It's in group 17. So it's a -1. So this will just be Hi. For acids, you want to get in the habit of writing the suffix. I'm a little lazy about this myself. The subscript AQ, which means aqueous, which means in water. Okay, all acids are in water. All right, the last one going this direction is sulfurous acid.
Professor, what's in the parentheses again?
AQ.
Thank you.
All right, now, sulfurous acid, we know it's an acid. It is not a binary acid because it doesn't begin with hydro. So it's going to be H. And then the way to figure out the other ion. So this is where it says it in the little box. If the ion ends in ate, the acid will be ic acid. If the ion ends in ite, the acid will be the us acid. All right, so this is us. So sulfurous would be from sulfite. Now, if you look at your polyatomic ions, that's a Word document. Let's see, it's right here. Sulfite, is sulfite even on here? Yes, it is. It's SO3 2-. Okay, so that's SO3 2-. So if you put these together, it'll be H2SO3. And again, I usually don't take a point off if you don't write AQ, but when you're in Chem 200, they will. All right, so you see if the acid ends in us, it's going to be from the ion that ends in ite. So sulfurous, sulfite. All right, that's going that direction. So then the rest of it is doing the same thing, but backwards. And it's, again, a lot of your equation stuff we're going to do is going to be written in words. So you have a lot of chance to practice this. I can't stress enough, you know, you guys have been really good. You're on top of things. You're coming to office hours. This is something, if you are a procrastinator, this would be a time not to procrastinate. You need to do nomenclature, especially in a short term like the 8-week term, because you really got to get it down quickly. All right, to write names, BeF2. Okay, so we look again. Be is a metal. That is this. Be is right here. It's a metal. It's a representative metal. Fluorine is a nonmetal, so this is an ionic compound. So ionic compounds, we just name the ions. It's a representative metal, so it's just called beryllium. And nonmetal ions end in ide, I-D-E, like dog. D like dog. So spelling counts. Sulfite and sulfide are very different, but that's just called beryllium fluoride. All right, KC2H3O2. All right, so again, K is a metal. This is called potassium because, again, it's a representative metal. How do we know? We find it on the table. It's right here. It's a representative metal. So we just call it the element name. This is obviously a polyatomic ion because there's more than one element. And so we just look at that and we go, we got to find that one. Oh, there it is, acetate. Acetate sometimes written differently if you look it up on the internet, but this is how we do it in Chem 152 and in 200 really. C2H3O2. And so this is called acetate. And that's it, potassium acetate. Just name the ions. All right, this one's going to be trickier. PbI2. All right, so lead is right here. Lead is not a representative metal. Representative metals are in group 1, group 2, group 3, group 13, and then zinc, cadmium, and silver. Everything else is going to be called a transition metal. And the thing is they form more than one ion. So how do we know? So we know that this is going to be called lead something, and that's iodine, but it's iodide. So we need to find the charge on the lead. So the way we can do this is that same thing I did before, but do it backwards. That's the charge on the lead. Iodine, we know, is a -1. From the formula, we know that there's 2 of them. That means that there's 2 negative charges. If there's 2 negatives, there have to be 2 positives. From the formula, there's only 1 lead, so lead has to be a +2, and so that is lead 2 iodide. Okay, so I kind of went around the block a little bit. I don't know the charge. I can't just look at it because it's lead. Lead has a 2 and a 4. Right? I don't know which one it is. And you don't even know that lead has a 2 and a 4. You just need to know that lead can have more than 1. But we always know the charge on the negative ion. And we know from the subscript how many there are. Right? So I'm going to do the same thing again with the tin compound over here. SnSO4, is it a 2? Yeah. Okay, so tin, like lead, is not a representative metal. So this is going to be called tin something sulfate. That's a polyatomic ion, so we know that one. Right, that's an E. So same approach. Sn, we don't know the charge. Okay, SO4, however, we do know the charge. It's a -2, because that's on my list. From the formula, we know there's 2 of them. That means there's 4 negative charges. That means there has to be 4 positive charges. From the formula, there's no subscript on the tin, therefore there's one of them. That means tin is a +4 ion, so this is tin 4 sulfate. So kind of keep in mind, first that you have to do this, then it's just figuring it out. All right. Almost done. It won't be late either, that's good. All right, NH4OH. Okay, this is 2 polyatomic ions, and again, it's a recognition thing. This is ammonium, and OH is hydroxide. Where is hydroxide? It better be on this list. Hydroxide is got. How is hydroxide? Oh, there it is, right there. OH. All right. So ammonium. So all ionic compounds, you name the ions. That's it. It's just the problem is that there's 4 kinds of ions. There's the representative metal ions, the other metal ions, the non-metal ions, and the polyatomics. Okay, let's do the next couple. So you see that first step, what kind of a compound is this? Is huge. Got to know that first step. Okay, so P2O5. And then the next one is NH3. All right, P2O5, phosphorus and oxygen are nonmetals, so we don't worry about charges. So it's just phosphorus oxide, but it's 2 phosphorus, so it's diphosphorus. I'm going to write, and then pent, 5 is pent, like the pentagon. That's it. This one, there's 2 compounds I told you to memorize that because the common name is used. This is ammonia. So you don't want to call it like nitrogen trihydride. It's called ammonia. And by the way, this one, this is called water. It's not dihydrogen monoxide. It's water. Okay. I just told you, got to memorize those 2. They're very common names. All right, the last 2. Then I'll shut off the recording and answer questions. And then, like I said, I'll stop the Zoom session and then reopen it for lab. So HCl and HNO3. Okay, so both of these are acids. You know that because they begin with H, except for H2O if it begins with H. So this is something acid. Now, as far as acid, how do we know this is a binary acid? Because there's only two elements. So binary acids here, if it's binary right here, we just call it hydro and then whatever the stem name of the other element, ic acid. Hydro, and this is chlorine, so hydrochloric acid. In fact, I think that's not the example I gave you. So this is going to be hydrochlor for the chlorine, ic acid. Now, this one's also an acid, but this is not a binary acid. So the way we do this, we do that 8 ic I us. All right. So this, you look at this ion. So NO3 is nitrate. How do we know that? Because we looked it up either in your head if you haven't memorized. So if you memorize it, you're looking it up between your ears. Until you get there, you're looking it up on the polyatomic ion list. Nitrate, so that means nitrate will be nitric. 8 ic. Like I was telling someone in one of the breakout rooms, I don't know who came up with this system, and I don't think it's the best system in the world. I don't get to teach the system I'd like it to be. I have to teach the system we have. So this is called nitric acid, which is a particularly nasty acid. All right. So that's a good set of them and examples on how to do them. There's a lot in the slides and videos. When I give that that lecture in a standard lecture, it takes me about a lecture and a half to go through those slides. That's why I broke it up into 5 videos. All right, I'm going to stop the recording and then I can answer questions. Let me just get out of the screen share and we're stop recording.